Hi, in this video I'm going to go through part I of question 1 on the Math 2010 paper. So we're told that I is a function of a, where it's equal to the integral between 0 and a of 4 minus 2 to the power of x squared, and a is a positive number. And we want to know when is dA going to be equal to 0. Okay, so let's have a think of what this integral is like. So let's try and draw the function 4 minus 2 to the power of x squared. Well, when x is 0, this 2 to the x squared term is going to be 2 to the 0, which is the same as 1. And so this would be 4 minus 1, which is 3. So it's going to start off at 3. And then we see that when x gets bigger, 2 to the power of x squared is going to be increasing too. And so because we're taking something that is getting bigger and bigger away, then this 4 minus 2 to the x squared is going to be getting smaller and smaller overall. So our function is going to look something like this. And then this integral is just going to be the area up to a underneath this curve. So we see if we increase a, we're going to end up with a larger area right up to when a is at this point here. But then after this point where the graph crosses the axes, we're going to be adding on a negative area to our integral. And as we make a bigger and bigger past the point where it crosses the axes, then the negative area that we're adding on is going to be getting larger and larger. So we see that the integral is increasing as we increase a up to this point of intersection, and then past this point of intersection we see that our integral is going to be decreasing because we're adding on negative areas. So our IA graph is going to be like this, where this maximum is going to occur when a is at this point of intersection. And well, if we want dA equals to 0, then we're going to need to know when and for what values of a this maximum is going to occur, because that's when its gradient is 0. So we need to know when this curve intersects with the x-axis, i.e. when 4 minus 2 to the power of x squared is equal to 0. The a that makes this derivative 0 is the a that makes this equation 0. So if we rearrange this, we see that we need 2 to the power of a squared to be equal to 4. And 4 is the same as 2 squared. And so from this, we see that a squared is going to be equal to 2. And well, we know that a is a positive number, so if I just square root this, then we see that a needs to be square root of 2, which is b. Now, one way you can check your answer to this question is with the fundamental theorem of calculus. So this isn't something that you would be expected to know from school, but it's quite useful for checking this question, and basically says that if you have a function which is the integral of a continuous function, then the derivative is just the thing that's inside your integral. So for our question, I of a was equal to the integral up to a of 4 minus 2 to the power of x squared. So its derivative with respect to a would just be 4 minus 2 to the power of a squared. And so if we want this derivative to be 0, then we get that we need 4 minus 2 to the power of a squared is equal to 0. And then this algebra is just the same as what we did before. So I wouldn't use this to actually do the question, but it is quite a good way to check.